Now students, you have already seen videos related to projectile motion. Now for just introduction, I'll tell you that what is a projectile. It is a name given to any body which once thrown into space with some initial velocity, it moves thereafter under the influence of gravity alone without being propelled by any engine or any fuel. And the path followed by that projectile, that body which is following the projectile motion, that path followed by it will be known as its trajectory. For example, you can take any object dropped from an aeroplane, it follows projectile motion. A stone thrown horizontally from the top of a building, these all could be example of projectile motion. Now before studying projectile motion, we have a principle of physical independence of motion. According to this principle, projectile motion is considered as a combination of two independent motions. First will be the motion along horizontal with some uniform velocity, and second will be the motion along vertical direction under gravity with uniform acceleration equal to small g. Okay. Now, the first case in projectile motion is projectile giving horizontal projection. You have already seen it in the video. So, I will just explain you the important conclusions we draw from it. In projectile given horizontal projection, as you can see in this figure, the horizontal motion is due to the uniform velocity and the vertical downward acceleration. The projectile, suppose this is the object at point O, it is moving horizontally also and vertically downwards also. So horizontally it is moving with uniform horizontal velocity u, and vertically downwards it is moving in an accelerated motion with constant acceleration g. Fine. Then if we find the trajectory of this projectile, I told you trajectory is the path followed by the projectile, so it will come out to be y is equals to kx square. As it is a quadratic equation, therefore we can say trajectory of the projectile is parabolic. Fine. Next we find time of flight. Now what is time of flight? So it is the total time for which the projectile remains in its flight. Okay, total time. Suppose a bullet is fired with some initial velocity u. Now when the bullet it comes to the ground, the time it has taken from initial point when it was fired till the final point it reaches to the ground. Fine. So it will be the total time of flight or total time taken during the flight, that is known as time of flight, and it will be t is equals to under root 2h upon g, where h is the vertical height, okay, and g is acceleration due to gravity. Fine. Now horizontal range. If we talk about horizontal range, as you can see in this figure, this YA distance is covered by the projectile. Okay. So horizontal distance or horizontal range is the horizontal distance covered by the projectile during its time of flight, and it is given by r is equals to u, which is the initial velocity with which it was projectile was fired. Fine. U under root 2h upon g. So you can see time of flight and horizontal range, there is just a difference of this u, okay, else they both are same, but if you multiply u with this time of flight, you will get horizontal range. Fine. Now next is velocity of projectile at any instant. So if v is the velocity and vx and vy be its components along x-axis and y-axis, then v is equals to under root of vx square plus vy square will give you the velocity, the magnitude of the velocity. And here in this case, as you can see, the horizontal velocity is u, and what will be the vertical velocity? The vertical velocity will be u plus at. V is equals to u plus at. In this case, we have when we talk about vertical motion, this v will become 0 plus gt. So v for vertical motion will become gt. Fine. So that is why we are putting its value here. So we get v is equals to under root u square plus g square t square. Now to find the direction, we'll have to find the angle. Okay, tan beta is given by vy by vx. Vy is gt. We have just find it out, and vx is u. Fine. So we will get beta is equals to tan inverse gt by u. Fine. Now I suppose that these are the important terms related with projectile given horizontal projection. Next we have projectile given angular projection. Okay, or we can say projectile is fired at some angle. Fine, as you can see in this figure. Okay, this projectile has been fired with some initial velocity u, making an angle theta with the horizontal. Fine. Now in this case, if we find the trajectory of the projectile, first of all, what will be the horizontal component of velocity? It will be u cos theta, which remains constant throughout the motion, and vertical component u sin theta, it changes with time under the effect of gravity. Okay, so this u sin theta, it first decreases, then it becomes 0 at the highest point A, and after which it again increases till the projectile hits the ground. Fine. So talking about the trajectory of the projectile, it will come out to be y is equals to px minus qx square, which is again a quadratic equation. That is why the trajectory or the path followed by this projectile when fired at an angle is also parabolic path. Okay. Now time of maximum height. See, in this diagram, this is projected at an angle theta. Now it will reach a maximum height at this point. Fine. So we are talking about this maximum height, hm. Fine. So time of maximum height, the time it has taken to reach to that maximum height is given by tm, small tm, and it is equal to u sin theta upon g. Fine. Now next is time of flight. So what is time of flight? It is a total time taken by the projectile to reach the ground. Fine. So total time will be, I think it will be double of time of maximum height. Yes. So total time of flight or time of flight will be tf is equals to 2u sin theta upon g. Okay. Now maximum height of the projectile, the maximum height it has attained, it will be equal to hm is equal to u square sin square theta by 2g. Fine. Now if we talk about the horizontal range, which means the horizontal distance covered by the projectile during this projectile motion, it will be given by r is equal to u square sin 2 theta by g. Students, this is very, very important, very important. Okay. And why I am telling you only the important points? Because you need to understand and practice these expressions, as these will be used in each and every question which you will do for projectile motion. Okay. Now this is very important. See, this is very important. Condition for maximum horizontal range. When will we know that maximum horizontal range is given by u square sin 2 theta by g? Now when will this r be maximum? We know that sin theta is maximum when its value is 1. And when is sin theta 1? When is sin theta 1? When it is 90 degree. And we have here sin 2 theta. It means sin 2 theta will be maximum, which is equal to 1 when sin is 90 degree. Fine. So we can say that 2 theta is 90 degree. So from here we will get theta is equal to 45 degree. It means when theta will be equal to 45 degrees, then that will be the condition for maximum horizontal range. Fine. And how can you find the maximum horizontal range? By putting this value in maximum horizontal range, we will get u square sin 90 degree by g, and we know sin 90 degree is equal to 1. So we are left with r is equal to u square by g. This is the maximum horizontal range, which is very important. Very important. Okay. Now we have next two angles of projection for same horizontal range. For the same horizontal range, there could be two angles of projection. That is what we are going to see here. We know r is equal to u square sin 2 theta by g. Now we replace theta in this expression by 90 degree minus theta. Fine. If we replace it, 2 will get multiplied inside. So we are left with 180 degree minus 2 theta. And sine 180 degree minus any angle is equal to sine of that angle. So here we have sine 180 degree minus 2 theta. That is why solving this we get sine 2 theta. Fine. So solving this u square sine 180 degree minus theta, we will get u square sine 2 theta upon g, which is same as r. So r dash is equals to r, which means when the angle was theta, then also we have the same horizontal range, and when the angle was 90 degree minus theta, then also we have the same horizontal range. So we can say that for theta and 90 degree minus theta, we will have same horizontal range. Suppose I have theta is equals to 45 degree. Fine. So what will be 90 degree minus theta? It will also be 45 degree. Yes. Or I say I have theta is equals to 15 degree. So what will be 90 degree minus theta? It will be 75 degree. Okay. So for 15 degree as well as for 75 degree, we will get the same horizontal range. Okay. Similarly, you can find for more angles also. I hope you all have understood till here. In the next videos, I will explain you uniform circular motion, as well as I will explain you some of the important numericals related to projectile motion and uniform circular motion. Thank you, class.